Hi, welcome to the International Space Station Flight Control Room. It was a really exciting night last night. We had Expedition 38 ending with the departure of that Soyuz TMA-10 and with the 3 crew members aboard. Were you able to watch the landing?
Yes, I had it queued up at home.
Great.
Watching.
Well, with the departure of Expedition 38 crew, that kicks off the Expedition 39 mission. And so here with me today, we have the space station program has a plan for science on Expedition 39. And so here with me today, I have Yuri Guinart-Ramirez. I said that correct, right? Good. And she is the Expedition 39 increment lead scientist. And so she's going to talk to us a little about what science activities we're going to be doing.
Okay, thank you very much. Essentially, we are very excited this increment pair to start, kick off, continue with the research we have started. One of the focus areas for this increment will be a lot of the external platforms that we continue to attach to the International Space Station. And one of the unique vantage points for utilizing the space station for external viewing is, of course, its location, its ability for different platforms to access it on a much lower cost than they would have to if they had to incur launch and all of those pieces separately. And its ability to both monitor Earth and continue to collect data on Earth sciences, as well as a window to the rest of the universe. So for that, we have, during this expedition, SpaceX 3 is currently planned to launch in a few days, and it will be delivering 2 additions for instruments to space station. One of them is the HDEV, which will allow a high-definition view of the Earth, and main concept is to test cosmic impact on the cameras and figure out how we can further that technology. Mm-hmm. The other external platform that's coming up with SpaceX 3 is Opals, and this is a pretty interesting device which is going to continue to advance our understanding on communication via laser. And essentially from JPL there will be a beacon that will be sent when the space station is scheduled to pass over, and it will lock in with the Opals device, and the Opals device will send a video down via laser communication, and that hopefully will advance our understanding and ability to communicate a lot more data in essentially a faster time.
Right. So we're kind of talking about some of the science, the activities that we'll be looking at outside the complex. But real quick, let's just back up a little bit and explain to me what goes into the planning, like being the increment lead. You know, you're assigned this is going to be your mission, and what kind of science? How do you go about? You know, what are the priorities and what things we're going to go ahead and begin?
Well, we start off with the planning of a research complement, if you would, for an increment pair. In this case, 39 and 40 will go together. And when we start that process, roughly 12 to 18 months in advance, collecting inputs from the various scientists, and this is a multilateral effort with our USOS partners involved as well. And all of that comes together. There's a special group that puts all that plan together and looks at all the different resources that you need, including the crew time, power, up mass, down mass, cold stowage, etc., and all the different resources that might be needed for a particular investigation. They put all that plan together, and as they look at all that, the priorities are always looked at from 2 different perspectives. You have your long-term range goals as well as your short-term, and there are, depending on the resources that each investigation needs, you look at viability of the samples and whether or not you can repeat something if you don't accomplish it within a certain time period, and how much of it impacts loss of science versus just a deferral of a particular data collection. So all of these different pieces are put together, and we inherit that after the strategic time frame into the tactical time frame about, well, roughly a year about approximately before the increment starts. And then we continue that process as the science matures and we understand the investigations better and vehicles move and adjust those investigations with the priorities. We work together with the stakeholders and make sure that we continue to understand all the different pieces where impact the priorities.
Mm-hmm.
And then right now we are starting now the real-time process, and what we continue is a dialogue on a weekly basis through the IRT, which essentially convenes multilaterally, as well as we review every week. 4 weeks look ahead. We start looking at the science complement and the priorities adjustments as necessary.
Okay. Well, a lot of planning goes into this. So so we talked some about the research that's going on outside the complex, but the crew members themselves are actually research subjects. Can you tell me some of what human research projects or studies that we're doing right now for Expedition 39 and 40?
Certainly. We have a continuation of a lot of our human research subjects that have started in previous expeditions.
Mm-hmm.
We continue certainly to make additional collections on ocular health, which is a big priority to understand what the visual impairment for the crew members can be due to microgravity. So we will continue definitely with those investigations. We also have continuation of other investigations, for example, microbiome, which it's pretty neat. The best way I can think of describing it is you look at the human body as its own little microcosmos, if you would, and all of the different organisms that live in the human body have to be living in harmony for your immune system to work correctly and in balance so you don't get sick. And
that happens here.
Exactly. And in microgravity, it's even heightened. So we're trying to understand the environment interactions with that microbiome, which is the human being. So that's a lot of exciting research in that regard.
Great.
We also have a new investigation during our increment, and this is a JAXA feature investigation that strives to understand if we can devise a good countermeasure for muscle atrophy. As you know, with 0G, muscles suffer from that problem, and they are looking at a new way to exercise using an electrical stimulus to the muscles. Which would be, instead of having the bulky exercise devices that we have today, we could possibly augment that and even become a possible substitute for longer missions where you have a much smaller set where you adjust your electrical devices to the exercises that you will perform. In this case, we're going to do curls to assess how good that is and how positive of an impact it has on the muscle development. Well, that's a new exciting human research.
Well, thank you so much. That's a great overview. Again, that's a lot of the science. We have continued science. We have some new stuff that's happening, and you are officially there. And congratulations and best of luck to you. Thanks so much again for coming out today.
Thank you very much.
Thank you.